So I would like to say a few words before we go on. The first is that astronomy and observation of the sky has been certainly the first scientific investigation of humankind. It started almost 5,000 years ago in Mesopotamia. And this Mesopotamian astronomer grouped the star of the zodiac into the 12 constellations, which are the same as today. They also, They also noticed that what was called the morning star and the evening star were actually the same celestial body, which is Venus. So this was a fantastic discovery, first one really scientific. They used a mathematical system with a base of 60, which is now used to divide 1 hour in 60 minutes and 1 minute in 60 seconds. And their calendar initially was 360 days. So this is why we measure the angles, 360. Now, most of the remains of this Mesopotamian astronomers have been lost. So how do we know about it? We know about it because this is the first alphabet, the first known complete alphabet, which was found in Ugarit in Syria. It's a small tablet like this. It's Beckett clays. I hope it still exists with all the problems in Syria. But anyhow, I was lucky enough 10 years ago to see it with my own eyes. And this, deciphering this, has allowed to interpret what is called today the Venus tablet. And if you are able to read it, I'm not, so I have to believe what people say, it gives the rising and downing of a morning star and evening star over 21 years, the exact hours. So this is the first text establish a periodic astral movement. It is absolutely fantastic that 5,000 years ago, mankind was able to produce this kind of document. Then we have what one can call the Greek miracle. I wanted to show off with my Greek friends, and I hope it is correct. It's okay? So this means the Greek miracle, Aristoteles, Eratosthenes, Aristarchus, and Thales of Milet. When I was a kid, the age of your students today, I was absolutely fascinated by Eratosthenes. He was born in Cyrene, lived in Alexandria, and died in Alexandria. And these drawings is very similar to what I had in Enciclopedia dei Ragazzi in Italy for kids. And this Eratosthenes noticed that on a particular day, the summer solstice, the sun would go down to the bottom of a well drilled in Sian. Today we would call it Aswan, while the shade of an obelisk in Alexandria made an angle of 7 degrees and 12 minutes. And from that, assuming that the Earth was a perfect sphere, he could say that the radius of the sphere was 6,366 kilometers. The value we give today is just 5 kilometers away from what he calculated. This was, for me, there was no internet, nothing of the sort. It was also in my mind, and I dreamed about that. And I also dreamed later on about what was going on 1,000 years after Eratosthenes on the other side of the Atlantic Ocean. Here we are in Yucatan at Chichen Itza. This pyramid, which the Spanish call El Castillo, is a Mayan construction. And it is not a simple one. First, oops, sorry, I have to come back. There are 4 stairs, 2 on the side. Each one has 91 steps. So the 4 of them make up for 364. And there is an additional step here, so that is 365. And the Mayan astronomer also calculated that it was not exact, but you had to add some kind of 0.25 days every year. So this is exactly what we have today within a few seconds. There is more to this. The angle here and here is calculated so that if you go there on the solstice and equinox, the shade at the sunrise, the shade projected on the side of the stair makes this kind of undulation here. And it looks like it is the snake going down. The snake is the famous Quetzalcoatl, the sacred snake. And this is not only in Chichen Itza, but also in smaller temples like here, Chibil Chaltun, not far from Merida, not far from Chichen Itza. It seems like a very simple temple, and it is. But again, if you go there at equinox, this is taken on the summer equinox, at 5 o'clock, then you find something absolutely fantastic. The sun goes through suddenly, and so it shows that there is a huge calculation behind that, astronomical calculation. And this calculation was done here. This is what is called, it is the observatory in Chichen Itza. This part here is called Caracol, El Caracol, again in Spanish. It means the snail because of its shape. And this is the place from where all observations were made. There were no instruments at the time, only eyes. But the Caracol itself is a monument to astronomy because its orientation, everything is not a simple one. For instance, the diagonal of this is such that the summer solstice at sunrise comes out sunrise here and sunset here in the winter solstice, and so on. And then we jump back to Europe, and we have a real takeoff of astronomy. So with Copernicus, Tycho Brahe, Kepler, and Galileo. And we have a fundamental date for astronomy. August 21, 1609. Galileo presents his telescope to the Senate of the Venetian Republic, the Republic of Venice. You know that Venice was rather independent. They had a huge marine float, so the first use was not for looking up, but for going very far to see if other ships were arriving. Galileo was not the first one to think of this. He certainly was inspired by previous work of a Dutch guy, Hans Lippershey, in Utrecht. He was a lens maker. This is a copy of Galileo's telescope, which you can see at the Museo delle Scienze in Firenze, in Tuscany, Italy. Tuscany is my region, so very proud of that. And this is one of the drawings, one of the first drawings by Galileo. He could observe exactly the phases of the moon. And here is a scheme of his telescope. Now we jump from Galileo to the 20th century. Another date, April 24, 1990, Hubble, the NASA ESA spatial telescope. Right now, not only we can observe the universe, but also we get rid of the atmosphere, which always makes fluctuation. So this is also a very important date. Notice that almost 3,000 years elapsed between the Mesopotamian astronomist and Galileo, but only 380 years and 9 months between Galileo and Hubble. So it is a huge and fabulous adventure which is going on. And what we will try during this gift workshop is try to make you participate in some way to this adventure and pass it over to your kids. So until yesterday night at 10, we had this beautiful program, and it changed a little bit. And I will explain later how it changed. The speaker was scheduled to speak after me is Özgür Karatekin from the Belgian Royal Observatory, but he's blocked in Brussels. His plane was cancelled. But all this, Paul Brekke from Norway, Christian Kober, not far from here, because he's in the Vienna University, and Philippe Lonunier from Paris. Tomorrow they will speak about the solar system. Then we have tomorrow a session of exploring beyond the solar system. On Wednesday, the future program of ESA, essentially by Olivier Vitas. Incidentally, Michel Mayor is a Swiss astrophysicist. He is the guy who discovered the first exoplanet, meaning a planet belonging to not to the solar system, but to something else, farther away. And Athena Koustanis is working in Paris, originally from Greece, as her name shows, and she has written a very beautiful, interesting book, Life Beyond the Earth. Olivier Vitas will tell us about the new development at ESA. And we end up with a very, I anticipate a very alive communication by Matt Taylor here. Matt is responsible for the Rosetta mission at ESA. Initially, it was supposed to have an ESA astronaut, but he was taken ill and could not come. And now, with this, we have also some treats for you. And particularly, we have a video by Anna, I should have added Elisabetta Merlini, sorry. And she will explain what the GIF K and not the GIF T means, right in the afternoon. And soon after Anna, we have Barbara Ferreira, who will come. She's our media officer at EGU, and she will come and she will talk about Planet Earth, a program for kids, for about 10 minutes. And we also have some hands-on activity this afternoon, starting with Sophie Allen, Andrew McMurray, and Diane Carrere. And for this, we will split into two groups, as I already explained. And in the afternoon, in this hands-on activity, we'll explore the Kepler's second law. And when you do this experiment, which is a really nice one, please think that when Kepler established this law, he had no telescope. He only had his eyes. It's absolutely unbelievable that he could do such a beautiful construction with only his eyes. And today, after Paul Breck presentation, we also have, not tomorrow, but today, because of a change in the program, a video, The Northern Lights, by Paul and Frederick Broms from Norway. And also, a treat will be to go tomorrow to see the NASA Hyperwall. Three scientists from NASA will present it. I cannot say much about it because I haven't seen it yet. But I've heard from what the success they had in San Francisco that it is really impressive. So Özgür managed to have them, and we will have to go down. They are in the lobby. Now, the GIFT workshop is sponsored by EGU, but also by other organizations. For instance, this year, ESA, Istituto Nazionale di Geofisica e Vulcanologia, a small association, EDGEA, and an American company, 2G Enterprise, who gave the Gori Award, which was incidentally given by the Nigerian teacher who could not come. Yesterday, you already got some very beautiful atlas by Westermann, which is a publishing company in Germany. If you have not received it, there are some more to be distributed. And then these are two programs of run by GeoAzur, which is in Nice. Jean-Luc can explain everything about it on both, and inside is a program, scientific program. Now, not only we have sponsors, but we only have many other people who have worked on that. And we hope that most of what you will hear today will be useful in your classrooms. And of course, we would like to go on every year to have this kind of meeting among the teachers. But this depends that we get some money every year on our ability to show that you have really used what we have tried to pass over to you in your classrooms. So far I've told you about what we give you, what you get from coming here. Now I am going to tell you what we also expect something, but we also expect something from you, which is really important for the continuation of our program. So precisely, we ask you to fill in the evaluation form, which I will email tomorrow morning to all of you as soon as possible, and then email them. It is a very simple form to be emailed either to me or to Francesca Cifelli in Rome. Just your name, school name, and then you rate the impact that the GIFT workshop has had on your teaching. Also, we would like you to make a presentation of your experience at GIFT to your colleague in your school or neighboring school. This can be done when you go back or later on during the year when you have started using it in your school. And finally, it is okay that you do this, but we have to know about it to make it clear to our sponsoring authorities. So please send us all the reports and photographs of these meetings with your colleagues, and reports should be in English, even approximate English. But when I get a report in French or Italian or, I don't know, Bulgarian, I cannot use it. The only official language is English. So please make an effort to... And now I would like to answer some guidelines for a question which I've heard very often. Can I come back to the gift workshop? First, when I am asked this question, I'm very happy, because it means that you liked it. But, of course, we cannot accept the same 80 teachers every year. We would like to expand to as many teachers as possible. So, nevertheless, we have about 10 to 15% of the teachers come back every year because they are some sort of guide for the new ones. And of course, these teachers are selected among those who have given us the reports. And bear in mind that we usually don't consider accepting more than one teacher from a particular institution every year. So if there are two of you from the same school who want to come, you have to come one year one, second year the other one. There will be two different themes in the two different years. So it is not... So I'm finished.